Okay. All right, Julia, let's talk about your question.
Yes, I had a question, and this is from Module 7 about the ANOVA.
All right.
And it's SPSS.
Okay.
When it comes to doing that post hoc test options, when it pops up kind of like that box on SPSS, and it gives you the options of LSD, SIDAC, Scheffe, are there common ones that we are using every time? Because I just follow the step by step, like that's what I'm doing right now. So when you say click here, I just click there and then I click in the next spot you tell me on the videos. But
Yes.
is there something I should know that's like the most common? Yes, because I printed that because that looked important. Um,
Yes.
okay.
So so that's a good question. Let me go back real quick. This is a little portion in module 7. It's a page there, right? So if you see module 7, it's towards the bottom here, the post hoc comparison, right?
Mhm.
And what that does is, right, when we run the ANOVA, the first result of the ANOVA, it is significant or not, just tells us that there is a difference somewhere, right? The ANOVA is the test that we use when we have more than 2 groups, so 3 groups or more, right? And if the ANOVA is not significant, then you can tell already confident state there's no difference, right? And so basically you're done, right? The groups are not statistically significantly different. If there is a significant ANOVA, then we go to step 2, where we use the post hoc. Post hoc means after the fact, right? And Julia, you asked a really good question, right? Are there common post hoc tests? And I typically use these 3 tests. You'll see in SPSS, there's different options that you can take, right? But for this class, we'll just focus on 3 of them. They're the common ones. And the LSD actually stands for least significant difference, which is the least strict test, right? So if there is a difference, this test will detect it, right? And you use it when you want to make sure that you not make the type 2 error. The type 2 error is retaining the null when there's really a difference, right? So that's when you use the LSD. The HSD is the test with average strictness. Sometimes it's also called Tukey test. Tukey was a statistician that developed this test. All right. So this one you can use when you don't want to be particularly strict or you don't want to be particularly lenient. And then the Scheffe, which again is the last name was the statistician, the Scheffe test is the strictest of the 3 tests. And typically there is so it's statistically significant less often than, for example, the LSD. Okay. And when you want to be really strict and make sure that you don't make the type 1 error, which is rejecting the null when actually the null is true, right? When there actually is no difference, then use the Scheffe.
And how do you know when to use each one? Is that
Okay.
something you're just deciding, like, well, I'm going to be strict with this test, or yeah.
Yes, that's a very good question as well, Julia.
Will you go by the values of it or the way what you're testing for? I mean, obviously for like I wouldn't do it by how the groups, like if you're testing more in 3, then it kind of takes a couple of these out of the way, right? we can't test on one when you have only one group.
Yes, so you by definition you have at least 3 groups, right? Otherwise, you could do the t-tests that we just looked at.
Right.
But if you're looking at 3 or more groups, now the question is if you want to be strict or not so strict, really is informed by your theory and your practical nature of your study, right?
Hmm.
So let me give you an example. If let's say let me make an example. Let's say we have a new medicine that helps with prevents COVID, let's just say, right? And we at all costs we would like to see if there's a difference, right? If there's only a minimal difference, we want to make sure we detect it, right?
What's the difference?
Sorry?
What's the difference? What's the difference?
Well, let's say headache symptoms when having COVIDs, right? Or let's go more extreme. The breathing obstruction and one of those symptoms that was related to COVID, right? If we say, hey, if we can reduce that just by a small amount, it's already worth it, right? Then we might use the LSD because we want to already small differences. We want to be able to detect them.
Okay,
right?
that's the least strict just because it's a small. Is that how you relating that together?
Well, let's say there's a small difference. The LSD will say that's a statistically significant difference just because it's less strict.
Okay.
If let's say we have the exact same numbers, there's a small difference, but we're using the Scheffe test, which is stricter. The Scheffe test will say there's no statistically significant difference, just by the way that the test is set up, right? The same numbers, the different tests will show different results. And you will see this when you run the ANOVA for your practice examples and you select the different tests, you can see the mean difference between the group is always the same. But the probability, the p-value, the significance, right? The p-value significance is all the same thing. That number will change, right? And with the LSD, it might be 0.03, which if we're testing at the 0.05 level, right, the 5% significance level, we would conclude that this is a statistically significant difference because the p-value is lower than 0.05, right? But running the same test with the Scheffe, it might give us a p-value of 0.06.
Oh, okay.
All right, and now 0.06 is larger than 0.05. So therefore, we would conclude that there's no statistically significant difference between the groups.
Okay.
Right? So the conclusion is different. And let's say if I were Pfizer, the pharmaceutical company that made that medicine for COVID, I might want to use the LSD. Right? However, let's say if you are a patient advocacy group and there were significant side effects related to this particular medicine, right? I might want to say we need to use the strictest test to show, to examine if there are difference or not, because we want to make sure that this is really a statistically significant difference, right? And therefore we're using the Scheffe test because that medicine comes at a cost, right? Now let's say the medicine was almost free, it didn't have 0 side effects, and it was widely available, blah blah blah. We might, even as a patient advocacy group, we might also agree with the LSD test, right? We might say, okay, yeah, we should try to detect, even if it were more lenient, right? The benefits of actually making that claim are meaningful, and that's why we also agree to use the LSD test.
So with the LSD test, would the p-value be 0.05 or 0.005? Will it be low as that to say that it's
So the theoretical value that we compare against, the 0.05, right, or the 5% significance level, that's
Yeah.
always the same, right? That's across these tests. That doesn't change. But the
Right.
calculated value, right, in this example, I just made this up, but it would be 0.03 with LSD, and it would be 0.06 with the Scheffe, and the HSD it will be in between those two somewhere,
Okay.
right?
I get it.
Now, you're asking a good question, right, Jeline? Because another way to be stricter is to change the significance level, the theoretical significance level at which we test against, right? And for this, let me go back to module 4, where we talk about hypothesis testing, right? And right, that's where you choose.
That makes sense to me right there. I'm just trying to place the LSD, the HSD, and the Scheffe with the p-value so I can understand where to
Yes, exactly.
how to word it.
Yep. Yeah. So this is a way of being more strict at our assumption level, right? So that's a way to say, hey, if we're going to pick, let's say we're picking the 0.001 level, right? The 0.01% significance level.
Mm-hmm.
We pick that ahead of time, right?
Mm-hmm.
So that right there tells us we're going to be very strict on how we test our hypothesis, right? So that's basically our first lever to do that. Okay. Now, we could still, when we actually then run the ANOVA, choose the LSD, HSD, or Scheffe test, how we calculate the p-value.
Okay.
Right? So you got two areas to kind of play with, right? And that's why, in social sciences, many times we use the 5% level, right? Or the 0.05 level. Yeah. And that's why if I in this class, if I don't say anything else, that's where we work from. But you could say at the beginning of this study, you could say, hey, we're going to pick the 1% level, or we're going to pick the 0.1% level. And I think
is it possible to get the same answer if we were doing the 5% or the 1%, no matter what the question is? Because I think the possibility would probably be the same no matter how you test. It'll just have lower numbers or higher numbers. Yeah. So
yes, Jeline, you're absolutely right. The probability that we calculate is gonna be the same. Like the probability will change based on the test, HSD, LSD, HSD, or Scheffe, right? In that example. But let's maybe take a step back and let's just go with the t-test for a second, right? Where we just have one probability. We have one formula. We get one probability. Actually, also there's different formulas, but to simplify, right? We get, no matter what we choose here, the p-value that we calculate is going to be the same.
Right.
Now, you're asking a very good question. Could our conclusion be the same no matter which level we choose here? It can, if the p-value is, right here, it's 0.001.
Right.
If the p-value is 0.00, in the SPSS, typically it just shows us this, right? If you double click on it in the program, it'll show you more digits behind it, but it typically cuts it off, right?
Mhm.
But let's say for this example, if the p-value is 0.0005,
Yeah.
right? If that's our p-value, then the p-value, it's lower than 0.001, it's lower 0.01, and it's lower than 0.05. So the conclusion is the same. When it starts to matter is when, also when it's 0.06, all of them are the same, not significant, right? Now, if it's 0.049, now it starts to change, right? If
Yeah.
it's 0.049, then it's significant at the 5% level.
Mhm.
But if you chose the 0.01 or 0.001 level, right? If we would have picked that one, we would still retain the null, right? We would still say, hey, at the significance level that we picked, it's not significant, right? Now, let's go to another example, right? Let's say we adopted the 0.01 level and it's 0.02. What would you guys conclude?
I would.
So
I
we,
would reject the null.
well, hold on. If let's say we pick the 0.1 level and we get a p-value of 0.02.
Then it would not be significant, right?
It will be not significant because it's higher than the 0.01.
So is that rejecting, or is that
That's retaining.
retaining if it's not?
Retaining. Yep, retaining.
Okay, I gotta get that.
And again, you know, that just takes practice. You kind of got to learn how to do this hypothesis testing, right?
Everything's opposite.
Right. But if we had 0.02 and we had picked the 5% level, what would you conclude then?
Then it would be significant because it's smaller than 0.05.
Exactly. So then we reject the null hypothesis, right? The null hypothesis is where we start from, right? That's assumption that there's no difference between the groups. And so, and that's why, to tell you guys a little bit of a backdrop about research, right? I at one point in time, I was in a study where we examined a reading intervention, right? And the students had done all kinds of stuff with group reading and peer support, and they gamified certain things, right? So we wanted to show is the motivation in those groups different than in kids that had a more conventional instruction, right? And our findings were at 0.051 for one variable that we examined.
Hmm.
So what would you guys conclude? We had picked a 5% significance level, and it was 0.051.
I would say it was not significant then, right?
Yes, it was not statistically significant.
Yeah.
Really, it was really annoying for us, right? Because our hypothesis was that all the things that we're doing are impacting the students, right? And so, but if we go by these rules, right, then we retained the null because the 0.051 is bigger than the 0.05. And actually, you could even say if it's 0.050, it's still not smaller than the 0.05. So you still would retain the null.
Mm-hmm.
Now, right? So you guys see how this works.
Mm-hmm. Yeah.
Now, what in order to discuss the results more in a differentiated way, though, we had to say, all right, we had the p-value of 0.051, which we retained the null. However, there is a risk that we make this the error, and it's the type 1 error that we claim that there's no difference, right? We retain the null when actually there is a difference.
Okay.
Right? Because who knows, right? If we had done the study again, we would have maybe had another test that would have been 0.049, and we would have been walking around town saying, oh, we have statistically significant differences, right? Could have also been that it would have been a 0.06 where we're like, oh, yeah, okay. Right. So you see that just from the rationale, there's a bit of a gray zone there, right? It's important for us to understand it's all about probabilities, right? What is the likelihood of us finding a certain result? And based on that, we interfere to the actual population or to the conclusions that we're trying to make about the world, right?
Mm-hmm.
And even let's say even if it was a 0.03 or 0.02 the p-value, and we'll be like, okay, we're pretty sure that this is statistically significant difference. Even then, we could make the type 2 error, right, where we claim that there's statistically significant difference, but it still could be that there's no difference, right? It's the probability is what it's all about. And that's why in the research process, it's so important to replicate findings in also different studies, right? That's really how you can build knowledge, is by repeating experiments or repeating studies. And if you find it multiple times, then you're getting more confident in your conclusions. And that's why maybe you've heard of have you ever heard of the replicability crisis in psychology?
I don't think so. I haven't. Mm-mm.
Right, look here. So the reproducibility crisis and the replicability crisis is a crisis that impacts the methodology of scientific research. Over time, it has been realized by several bodies that the results of many scientific studies are hard or almost impossible to accurately reproduce, right? So what they're talking about is that we have like one-off studies and we make all kinds of conclusions and claims, but when we try to replicate the study, we can't do it. We can't find the same finding again, which actually is pretty. It's so prevalent that we actually have we have a lot of the topics, and it's why most published research finding are false.
Yeah.
I think I did see this in the news recently.
Did you? Okay.
I did, yeah. I didn't read the entire thing, but I do remember something about this. Is this just around psychology, or is it in other things too?
I think it's in other things too. It's
Okay.
So I'm sure it's in education for sure. It's probably more prevalent in the social sciences.
I would think so, because there's so many variables that it's hard to replicate. It's hard to, every person's so unique, every situation you try to make exactly the same, but it's so hard to do.
Yes. And medicine is an area as well here.
Yeah, and samples, and then the material that they use is different. The what they use the test is way different. It gets different every year. They discover something different. Is that why they're always testing off what previous scientists has done to try to slim it down and make more sense of what they logically came up with?
Yes.
Yeah. Okay.
Yeah. That's why
you're statistics on something that you would some people do it, they just make up something, but usually it's someone trying to prove that it's not right or right, and it's over something someone already said.
Yeah, that's the whole thing, right? When the scientific process, and that's why hopefully that's one of the main goals for this course as well, for you guys to really become critical thinkers. And when you see a study that you can kind of, first of all, that this in the back of your mind, hey, there's always probabilities involved in that, right? And when we there's you name the subject, there's often different opinions about it, right? And one way to debate this in a systematic way is to use the scientific method, right? To say, all right, if we have certain hypotheses, certain theories, we should be able to make certain claims, right? Predict certain things, right?
Mhm.
So have certain hypotheses. And, if you are able to explain the world and the way it works, you should also be able to predict things, right? And the better you are at predicting what's going to happen next, typically the more support you have for your theory, right? And if your theory and your idea of the world is not very adequate, then your chances of predicting or explaining phenomena is limited.
Mhm. Is that why we have like the control methods? And because when you have certain things that you're looking for, it's like stricter. Like if you were testing for, just like if you were testing for high GPAs or whatever in school, you would get someone like has had all A's as opposed to someone who's having A's, B's, and C's, right? You have a particular population rather than it's a more controlled. Am I saying that right? Because you wouldn't say there's people that go to college and don't go to that's not into college, and then there's people out of college, and then you're testing how good their grades are. You probably want everyone from college or everyone in a certain discipline to do you wouldn't have it where it will be so many different variables. You'll kind of shut it down.
All right. I think I see what you mean. Yes.
Like for variables, they have to relate rather than just everyone in general.
Yeah, so let's take an example. For example, I did a study on the success of Fresno State freshmen, right, and how we retain them. And to your point, Jeline, one thing that we looked at is the high school GPA and the SAT scores, right? And so the people differ when they come into Fresno State,
right?
And we want to, for example, we can take that into account, right? So I did a study with freshmen where I developed a hope intervention, right?
Mm-hmm.
And that if we teach students about reaching your goals, what to do when you encounter obstacles, right? And the idea was the students that we teach this should do better than the students that didn't learn this.
Right.
Right. But to your point, right, what we did is we also said, all right, we have, let's say, I'll simplify it a bit, but let's say we have 200 students that learn and 200 students that didn't learn it, right? Our control group are the students that didn't learn it.
Mm-hmm.
But at the same time, we also controlled for the GPA and SAT scores.
Yeah, that's exactly what I mean. Yeah. So then you have a different group you can test from. Like you can break that up to 3 different groups of depending on their SATs. So you're going to get a different answer for the same testing again.
Yeah, and there's ways to imagine. Well, I often compare it with like a horse race, right? Mm-hmm. Let's say you have certain horses that are, taller and have more muscles, right? Or you have certain horses that are shorter. And what you do is with statistics, you can kind of adjust, right? And you can say the smaller horse, we're going to give it a head start, right? Where one of the horse, we're going to hold it back a little bit. So we're going to statistically make it seem like they're similar. Right. And so that we can compare at the end, hey, which horse was faster, right? Where you can basically adjust for that with statistics.
Well, that's what I have to learn how to do. I need to know how to do this so I can go and get my master's.
Yes, exactly. And then master, you can learn more about this. And that's, those are, we touch a little bit on that with the regressions at the end of this course. But that's really, we have an advanced course, which is called the ERE 289, which statistical modeling, where we go into more of that type of stuff. And that's what I really recommend to all of you to take this course. And you can also earn a certificate, by the way.
Oh, yeah.
But to come full circle here, right? If you look at this, I just happened to pull this up. So I can't really vet this article. This is Wikipedia. right? So with a word of caution, but what you see here, right? They're talking about the whole hypothesis testing aspects, right? And they're talking about the probability, right? They're talking about the p-value of 0.05, right? The probability level, right? So you see here what we just talked about in the course is referenced to in this article as well, right? And they talk about, you know, some fields use smaller p-values such as p001, right? But this is also, you know, you get a smaller chance of false positives, right? So you're testing stricter.
So
right?
false positive is type 2 error.
False positive one here is the hold on, I want to make sure.
Because you said if we do the testing and we have the marginal difference, type 2 would be claiming there's error when really it's not. That's a false positive, right?
Type 2 is when there is no difference, when there really is a difference. So the type 1 is the
Error.
Yep.
Okay.
Right. We're concluding that there is a difference to a positive when there really is no difference.
Okay. So okay.
Yep. And what you see here also, right, is to be able to test with a smaller p-value, typically we require bigger sample sizes.
Right.
Remember how we talked about the standard error and how the standard error is related to the sample size, right?
The sample.
Yeah, so the standard error, it becomes smaller, so it means you have more precise estimates, and that allows you, right? Imagine if you have two groups that you compare, and if you have small sample sizes, you can detect differences that are small. If you have big standard errors, even if you have the same difference, you can't really tell because the estimate is not precise enough, right? So you can see how now, hopefully that was helpful. Was this helpful or was this more confusing than anything else?
Helpful for me. So if I had a big, go ahead. I'm sorry, you can answer. I just keep on thinking. Go ahead. I'll wait for you. I'm sorry.
Oh, you're good. You're good. I mean, you answered my question.
Oh,
For
right.
sure. Yeah. I
so
mean,
if there's a big testing, if there's like a bigger population, because you said if there's a bigger population, then there's a bigger what did you just say?
The standard error?
There's going to be a bigger standard error. So that does that mean like if we were trying to, if we would test, we would do it under the test that's the strictest, the Scheffe, if we were dealing with.
So okay, just to go back, right? If there's a bigger sample size, the standard error will be smaller because we're more confident in our estimate of the actual, let's say if it's a mean, if it's an average, right? If the sample size is bigger, we're more confident in that estimate. And
but say we get it and we want to narrow it down even more because it's still at a spot to where it could be in the middle. So would we go for a stricter test or a more the lenient one? Would we go for the?
Oh yes, if we wanted to narrow it down more, we would go for the stricter test for the Scheffe in this case.
Okay. Yeah, you test more than once and narrow it all the way down to where there's nothing to narrow, right?
Yeah. I mean, you know, when you say test more than once, do you mean do the study more than once?
Yeah, do the study more than once. Like for us, we can do the study with the same variables in the same population or whatever.
And oftentimes, unfortunately, we don't have a shot to do it multiple times, right? But if we do, then that will be one approach, right? To do it more often. If we only have one shot, then we can be okay. We're gonna be strict on it, right? because
Yeah,
we want to
I wanted to do special education and how they teach. So I wanted to have a control group of that, whatever they're using currently right now. And then I want to introduce my teaching method, but then I want to be able to use different methods as the quarters go by. So to prove in a year, that they're getting better, or, they're improving, they're learning more. And my point is to prove that my teaching method has faster results, and also
okay, yeah.
so
So one thing is this, and that's important language wise.
yeah,
You won't be able to prove anything. You'll be able to find supportive evidence for your method.
okay,
Right, and that's really, if you want to really be on a safe scientific foundation, right?
Mhm.
Because even Einstein's relativity theory is not really proven. It just has a lot of scientific backing, right? Where many people might say, yeah, it's proven, but the word proof, there's some people that are very allergic to hearing that word, right?
Yeah, okay.
And by you saying, hey, I have supportive evidence,
Okay, that sounds
shows that you're a critical thinker, and you're mindful of, how much can you actually, what kind of claims can you actually make or not, right?
yeah. Yeah, 'cause I think it'll be to work with the same kid. I can get the same population and do
Yeah, so that's the thing, right? If we design an experiment, if you say the same kids, well, if it's the actual same kids,
yeah,
right, then what you could do is in special ed or in behavioral science, sometimes we have gosh, I'm blanking on the name right now. They're basically special studies where you do something and then you don't do it, and then you do it again and then you don't do it. Do you know what I mean? So it's kind of like a light switch that you flip on and off, and you see if the behavior changes over time, right?
yeah,
Because the thing is this, right? If you're doing the work with the same people, already the first intervention has an effect, right? So you don't know, would they have changed anyways or not, as an example, right? It could have been that, the weather changed or something else happened, and that's why they changed, right?
yeah.
Right. Or what you could do is to say, all right, I have a similar population, right? Two groups of special ed students, right? And now you can see, right? If you have two groups of five, right?
Mhm.
And let's say maybe you got three autistic kids and two kids with attention deficit or whatnot, right? And you
Mhm.
have a similar other group of five. Yeah, you it's better than just having one, right? But you still have a lot of variables there for these kids, right?
Okay, yeah,
Let's say you had 100 special ed students, all just with one particular diagnosis, and you have 100 that have also a comparable diagnosis, right? Now, slowly you have comparable groups, right?
right.
And then the other factor is the randomness. And you'll see in the ANOVA, when I explain the ANOVA, I talk about this, right? Now, they might have different home lives. They might live in different neighborhoods, right? Maybe they get different nutrition. Maybe their sleeping patterns are different, right? Maybe some kids play 5 hours of video games a day, right? Others watch YouTube, and right.
Yeah.
But through the randomness, right? If the group is big enough, all that stuff tends to even out,
Okay.
right? That's one way to do it. Or the other way is random assignment to groups, which sometimes is very hard to do, right? But that means you have 100 people, and then randomly you put them either in the control group with your method, or the intervention group with your method, or in a control group where they do something else, right?
Okay.
And because you put them there randomly,
That
the
makes
only difference between the two groups is your method, right?
okay.
And
Yeah.
that's why, from a research methodology, right, from a logic perspective, you can now say that the difference is due because of whatever you did.
Did. Okay, I got
Right.
it. Okay.
And to take it full circle, right? The ANOVA looks, what is the variation between in those groups,
Mhm.
and then compares with the variation between the groups.
Okay.
Right? So we use the variation in the groups as an indicator for the overall variation. And if the variation overall between groups is bigger than what it is within the groups, we conclude that there's got to be a difference somewhere between the groups.
Okay. That
Right? You'll
makes
see in the video, I'll use an example in the slides. I use an example with flowers and how they plants, how tall they grow.
okay.
And Fisher, who came up with that, it's a genius. It's a genius idea, right?
Mhm.
Because you know that there's random variation, whatever it may be, right? It could be kids learning in school. It could be plants growing in a field. It could be whatever it is, right? We have random variation, and then if we estimate that random variation, we compare it to the variation across the groups.
But how would I get to that? Would I do a questionnaire? Would I have the parents do a questionnaire?
Oh,
Um,
okay. That's another good question, Jillian. The variable that you're examining, it could be whatever, right? It could be something that you ask the parents, right? It could be a questionnaire, a psychological questionnaire about parents, or it could be a questionnaire that you ask the kids, right? Or it could be a school test that you give kids.
okay.
It could be,
I just wanted like a combination.
yeah, it could be it could be really anything. You
Yeah.
know, what you're looking at to examine if there's a difference or not,
Mhm.
that's then up to you to figure it out. Right?
Yeah, 'cause I just wanted to be like what I'm doing. I wanted to show that whatever I'm imposing on the kids is the difference. So I need to figure out how to get all that other stuff out and make it random variables, like a random questionnaire for the parents just for
So
their
yeah, so the questionnaire wouldn't be random, and if you take the ERE 220 class, you should have some that there we talk more about research design and methods, right?
yeah.
And there's one module specifically about experimental design or quasi-experimental designs, right?
Yeah.
And that's where now it becomes it goes about the theory that you have in mind and what you're interested in is now, is now crucial, right? Let's
Yeah.
say you're interested maybe in language acquisition, maybe you're interested in math skills, maybe you're just interested in social skills, right? Maybe you're just interested in focus, how well they can pay attention. All right. What are some things, right? So we could ask you if Julia and I were evaluators, right? We could ask you, Jeline, well, what does your program do? What do you claim it does?
So it pinpoints a specific learning technique that a child learns better. So each child, it's going to pinpoint if what type of learner they are. So we can use that type of learning for them to pick up and do better.
Okay, so how do you measure doing better?
I don't know. That's what I'm trying to figure out. What would make it like how did I show the way that I do it as opposed to how it's done now? How it's done now and what percentage they have now that they total out for the year. Of course I want to have a better percentage for what I choose. If I take a student and he's a better hands-on, so we'll go through hands-on. Maybe he learns better by writing it out. So we'll write it out and we'll do that type of teaching method for a whole quarter and then compare it to, because the whole thing is having a child learn the way they learn, how they pick up like me.
Yeah. So when you say have him do it, or the percent is higher, what is that? What have you do? How have you do them? Like write?
They would write everything out. Everything that we would voice out, it would be written down.
Okay, but what is it? What is it that they can do better at the end of the quarter, let's say?
Oh, they'll be able to understand what they're reading, so they can
Oh,
understand.
okay, all right.
Read
So,
comprehension. The comprehension will be better. They will
okay,
also be able to spell the
Yep.
spell
Okay.
as they're, and then it also helped their penmanship. The penmanship gets better the more you write, you learn how to,
All right. So what you could say, Jeline, is, hey, we're gonna have 3 assessments: reading, writing, and penmanship, right? And you would have an assessment, a quiz, or you're right, we will call it an assessment for each of these,
Okay.
right? And that, let's just say, for the example's sake, each kid's gonna have a score on these 3 variables, right? Those would be 3 variables, right? And let's say if we keep it simple, right? We could, let's just pick one to make it simple. Let's just talk about a writing score, or reading comprehension score, right? And that's actually exam 1 is an example along those lines, right?
Okay.
Right. If we have a t-test, if we have 2 groups, we can do a t-test, right?
Yeah.
So at the end of the quarter, you got the kids that did your method and the kids that did the other method. And each of these groups has an average, right? And then you can compare, is this average different from each other?
Yeah, that's what I need a comparison.
Right. And the null hypothesis would be there's no difference between the 2 means.
Okay.
Right? Your hypothesis would be, the alternative hypothesis for you would be, the kids that did your method are higher than the kids that did the other method.
Yeah, that's what I'm reaching for.
Right. And maybe the school or whoever does what they do already, they might say the other side, right? They say ours is going to be higher than Jolene's method, right? Just for argument's sake. Right. And so that's how you could do that. And if now, let's say there was a 3rd group, right? Let's say Julia had a method as well, right? We would have Julia's method, Jolene's method, and the school method, right? So we'd have 3 groups.
Okay.
And if we had the 3 groups, we wouldn't do a t-test, but we would do an ANOVA, right? And now that's what the module 7 is about, right? The logic would still be similar, right? We have a null hypothesis where we say all the groups are the same. And then maybe, let's say, Julia, your hypothesis will be that your method is higher than Jolene's and the school district, right? Jolene, your hypothesis will be that your method, Jolene, is higher than Julia and the school district, right? And maybe if I would play along, right, I might say, hey, I think Jolene and Julia, both of their method are both of these are similar, but they're both higher than the school district.
Okay, I get it.
You know what I mean? So you can make, with ANOVA, you can make more complex methods, right?
Yeah. Okay. Yeah. Okay. We get it.
You get it? All right. See, and that's how you can make use this this content for practical purposes, right?
And when we actually start, I know for me, this is my first semester in the program. When we move toward working on our project or thesis, do we kind of have someone who walks us through that process and applying what we've learned here to what we actually want to do?
Are you in which program? Are you in curriculum instruction?
Yeah.
Yes. So you'll have, typically your advisor will guide you through that. But then me, Dr. Yukimenko and Dr. Hong, which we're the 3 methodologists, we were also available to support you guys, right?
Okay.
So some of the advisors are really comfortable with statistics and all that. And some of them might say, oh, yes, I'm a little rusty, maybe go talk to Dr. Wandler or Dr. Yukimenko or Dr. Hong. And then we help with that as well.
Okay, perfect.
Yeah. So you can always feel free to reach out anytime.
Okay. Yeah, because doing it on SPSS and in my little notebook and everything is great right now. But when it comes down to actually applying it,
Yeah.
I mean, I know I'm going to need someone to support me. So
Yeah. No, that's what we're here for. And then that also helps to kind of, solidify everything as well.
Yeah, yeah. Okay. Well, you've answered all my questions.
All
And
right.
more.
Well,
So thank you very much.
thank you guys. I hope you enjoyed the conversation. I think this is was good to just kind of exemplify what it can what this can lead to.
Yeah, we made our own little classroom, so I'll be
Yeah.
back this week.
I know. Yeah, it was nice. Thank you. It helps a
You're
lot.
welcome. Okay,
Yeah.
great.
All right.
All right, you all have a good rest of your evening.
Thank you, you too.
Thank you.
Yeah.
You too. Bye-bye.
Bye bye.